It is. Hello, everyone. My name is Bryce Smith. Welcome back to the AI Revolution call, which we do every week. We have Cody Willard, Trading with Cody, hedge fund manager, here with us today. And we have John de Olivera, our resident AI industry expert, who every week teaches us a lot of new things about AI. So, hello,
He's
guys.
John's been working in AI for 30 something years. You always got to
Oh,
say
I don't know. 30 is a little strong there, but
25 years.
26. Yeah. 1998 for real.
Wow. It's a long time.
Yeah.
It was nobody believed that AI was even going to be possible when you took you were like, I'm going to Austin and working in AI. And I was like, AI as in like autonomous income? And you were like, no.
So one thing I just found, Lex Friedman, right, does all the interviews and everything. I just found he did an interview 2 years ago with the now the late Doug Lennon, who passed away, I don't know, 6 months ago, something, but who was my boss, who got me my start in AI. And they have a really long, I don't know, it's over 2 hour interview that they do. And so anybody who loves that long form could check out. And there's a section, he releases 15-minute sections of it and stuff. And there's one on OpenPsych, and OpenPsych was my product.
Did you watch the whole thing? Was it enlightening for you as someone who had worked there for how long did you work at OpenPsych? Maybe 10 or 15 years?
7 years. And I did pick up a couple of things. But mostly it was like, yep, there's that. Yep, there's like was things that everything old is new again kind of was still the case with what was going on there. I think the interesting thing is that while the particular type of technology used, of course, way predates ChatGPT and so forth, the kinds of concerns about what we at the time were just calling common sense intelligence, computers that understand the world. And now you see when they'll run some tests to see how one of the latest models is doing, and you hear a lot like there's a cup turned upside down on the table with a marble under it. Somebody picks up the cup and puts it in the microwave. Where's the marble? And they're all getting it wrong. And so there's still a issue with kind of common sense, understanding that something is not really held in the cup, that kind of thing.
John, the very first call we did, we briefly hit upon your history of how back then you guys were trying to do ontological approach to AI today. Can you just give us a quick 1 or 2 minute review of what that is versus what ChatGPT is? And as you're doing that, maybe talk a little bit, what kind of chips were you guys using? Were you just buying Intel chips and having a couple of servers in an Austin closet in a office complex or something?
It started with the machines that later got used. I guess it was later by like Pixar when they were doing their animations. So these Silicon Graphics workstation,
SPI, yeah,
and it was like one 5 cubic foot refrigerator sized Silicon Graphics machine per person. To go do it. And then it moved toward much more just desktop, just a good, powerful desktop machine being enough for what was being done then, because it was a different approach. And so what was different about the approach? Well, what's kind of making it now is machine learning. What that was symbolic AI. And symbolic means that you could talk about what was being thought about. Right now, when ChatGPT gets something wrong, we don't know why, what it was actually thinking at the time. It's all like a black box. But with this other method, everything was visibly kind of the kind of thinking process that was going on was visibly on display. It could take you through a whole long chain of the reasoning that made it think the thing that it thinks. So it's one of the differences there. And what the ontology part gives it, what Doug was just mentioning in that interview, like a grounding. It's like when you stand on the ground, the reason that you're pretty confident that it's like sturdy there is because underneath the ground that you're standing on is more ground, and underneath that is more ground. And think of the ground as being the reliable facts and rules that people actually agreed upon that the thing operates on, as opposed to it does what it does and we wonder why. It was like it does what it does, and and when you come down to it, we can land on these facts and rules about the world that we painstakingly entered by hand, 10 million of them over decades, to go and represent that knowledge.
And now when you do something with ChatGPT and it spits out the wrong answer and you're like, why did you get that wrong? Does ChatGPT even know why it got it wrong, or it just it moved on from what, like, does it even for a moment track its own analysis to get to its answers?
It really doesn't, and especially it doesn't if it does in some internal way, it doesn't in a way that it can communicate with its users or even its creators to say, here's why I said that or what I did. I have an example of that I just encountered today. I was trying out this tool from Icon Builders. They spoke at South by Southwest. They're this really big new 3D, they 3D print buildings. And they went and created, it's amazing some of the stuff that they're doing, but they went and created something that looks like it's basically built on top of like GPT. And it's for, you can kind of talk to it to get a building design. And it's doing this, but it's making all the same errors that like DALL-E makes. If you go and say, I want a 1-story building in 2 parts with a roof over the separated areas, etc. And it's like, sure, here you go. And it hands you back a picture. And it's not at all 1 story or 2 separated buildings, but it doesn't even know. It doesn't kind of have a connection between what it's saying and what it's like generating with, it's called Vitruvius, their AI, Vitruvius, from Icon Build. And it's like really cool. It's just not very smart yet. And I'm not even sure that it can be, because the ground it's based on is not well supported.
How much was the SGI refrigerator size computer that you guys were using back then?
I think it was $15,000 a person or something.
And it was for a license or for each piece of hardware?
No, piece of hardware, each like machine.
Was it, did they charge recurring revenue, or you bought the computer locked?
No, it's like hardware. You bought the hardware and you were good. Yeah.
And is it Windows based or Unix based or Linux? Unix. Yeah.
It was a Lisp machine.
Who bought Silicon Graphics? Dell or somebody along the way at some point?
Oh, I don't know what happened to them.
How about Cray? Did you guys ever use Cray computers?
We didn't. I mean, it definitely was the right time period. And at the time, Cray had this thing that looked like, I mean, basically it had cushions. You could sit on it around the outside of it, you know?
Yeah, the computer was behind you as you sat there, right?
Yeah.
Yeah, I looked at it. Bryce and I looked at some pictures of that the other day.
So it was it was another time, but it was super interesting, and it still is, right? But like I was saying, the idea, we didn't use the term AGI, we used the term AI, but we did talk about narrow intelligence, which is the more standard kind of machine learning stuff.
If you guys had access to H100, NVIDIA's, whatever, what's their new one that's rolling out? B100 or something?
Yeah, Blackwell B100s.
Yeah, if you guys had access to Blackwell computer servers, clusters, and a budget of $10 billion in 1996 or 97, whenever you moved out to Austin to work for
Psycorp.
What was it?
Psycorp.
Psycorp.
The Psych Project. Yeah.
So how much different would the trajectory and the technology have you guys? Would the company today be $1 trillion company? No, zero difference.
It just really wasn't. It didn't have the same functional inputs to go like say, oh, just give it more processor. I know that's the thing now, but that's because that's the way kind of deep learning works and transformers work. And so with other kinds of AI, that wasn't the thing holding it back.
We hear now that the biggest what's ML stand for?
Machine learning.
The large language model, LLMs, that the large language models of today have literally exhausted all the data they can get their hands on. They've sucked it all up. They've used it all. It's all being part of the input, and they've sucked out everything on the public internet. In 1997, the public internet was like a few GeoCity pages and Playboy.com. So what was like? Was there a time? Is there an inflection point where there was enough data on the internet that machine learning, with the powerful chips that were being developed by NVIDIA and others, was there a point where it got big enough that you could machine learn? Was that in 2005 or in 2020? I mean, we're still adding however many bits of information to the internet every day, right? So when did it become big enough that you could actually train a full model on a full AI model just on the internet's public domain?
I mean, I think the idea even that's what was the thing to do didn't happen until there was, like, I remember it as being a couple of phases. You know, first was neural networks at all being rejected in the 70s, early 80s. It was kind of Minsky wrote a book about this isn't going to work. Then it was in the 90s where Hinton, Jeff Hinton, kind of started to show that they do work. And then it was in 2010 or so, somewhere around there, that you had the first real breakthroughs in vision and, using these neural networks to go, wow, look, it recognizes whatever characters. It doesn't matter what they look like, or it can pick out what kind of animal that is, So it got to that stage. And then got to, the Transformer stuff started around, was it 2018? And yet the first papers on it were in the 90s, but they're really to where they actually would do something with it. And that's where they really were like, okay, let's go just suck in as much as we can, suck in more, and found out how valuable that was.
Amazing. Bryce, you got questions and comments in here?
Let's talk about what's the most exciting thing that John has seen in the last 7 days in AI, because there's always something exciting.
Well, it's the thing I sent to you guys, maybe it's a little off-center topic or something to go talk about.
No, it's a good topic.
But this is such a good representation of what can happen elsewhere. We saw with Sora, which was the one, you can create video that's very, very realistic, or of any kind, realistic or unrealistic, whatever you want, by just describing in with a couple sentences. And that was after we already had done that with images that you could describe in. Somebody won a art contest with a computer generated piece of art, beat real artists, but those kinds of things. There was the talk about all the effects of that. Oh, you're taking away jobs or creativity or the industry or whatever it's going to change and so forth. Well, like the Sora, that video example, you go, wow, at some point that's going to have a real impact on Hollywood or this kind of thing. Now along comes Udio, don't know which, UDIO, which
I'll share my screen with the website,
which is almost immediately going to start having an impact. Because it basically, with it, you can create music by describing what you want, whatever genre. I don't know. Are you able to play it? Will we hear it?
Yeah.
Yeah, let's try something.
Won't be. There's no problem with copyright, so you go ahead and.
Yeah.
Can you guys hear that?
Yeah.
This is all AI generated music.
So, the words are generated, the voices are generated. There are it can be a cappella or harmony or whatever. You have jazz and classical and rock and EDM, and some of it I mean I know I can't tell the difference between hearing it what I hear here and what I go hear on Spotify.
No, that sounded like a real song.
Yeah.
And there's just lots and lots of examples, and it's going to be user generated music.
So, John, Bryce and I were talking today about taking this, going back to even the video part of this. You know, the amount, in order to build a functional and valuable large language model like ChatGPT or Anthropic, it's requiring a minimum of, say, $10 billion investment in chips and servers and compute power. In order to do the music one, well, they're using the same model, the same LLMs, and so we're still around 10 billion. But in order to take that next leap and for someone, even a Netflix, to make a 2-hour-long feature-length movie with the quality that we have all come to expect from Netflix and or most major Hollywood studios, I'm picturing it's got like the biggest barrier to doing that right now is the investment in compute and the access to that kind of compute power. So we're picturing it's going to be tens of billions of dollars in order for someone to make a full feature-length 2-hour movie, and only Amazon, Apple, Google, Netflix are going to be able to afford to do that for the next, say, 3 to 5 years.
Well,
and that's what we want you to.
Well, I mean,
debate that.
First of all, it's not whatever $20 billion to make a movie. It's $20 billion to make a movie maker.
Correct. That's what I mean. But
So
it's
from
going
then
to
on,
cost the upfront. Yeah, you're going to be able to spread out those costs over hundreds or thousands of movies as you distribute them to your viewers on Netflix, for example. Mm-hmm. But you have to invest $20 or $30 billion upfront to have the technology that can actually deliver that kind of a lengthy, high-quality video. The example I gave Bryce earlier was I've written and recorded and produced 100 songs in the last 20 years with my rap, rock, country, folk, fusion band over the years. And sometimes we'll have 10, sometimes we'll have 25, sometimes it's 40 different tracks in one of those songs. And when I tell my computer today, I've got the latest, greatest Apple Mac computer to do that stuff, it can still take a couple 5 minutes to process and render that audio track, compress all those tracks into one and make it an MP4 that I can send around to people. MP3 in this case, music. But in order to do that with an MP4 in a video, I've also made movies, never a 2-hour length movie, but I've made music videos that are 4 minutes long, and it'll have 10, 15, 20 different tracks in it and all kinds of transitions from one track in one part of the video to the next. And it can take 10, 20, 30 minutes, depending on the quality of video you're rendering. If you want to do an 8K video, Hollywood length, 2 hours, and Hollywood quality, 8K, incredible scenery and everything else, we're not there yet. ChatGPT.
Of course, we're not there, but we're not there. But I mean, if I think about like how not necessarily far we are, I think that number one, what is a 2-hour movie? It's 120 minutes. What's 120 minutes? It's 120 1 minutes, right? It's not like the thing has to like, oh no, it can only generate a minute now. It has to get to where it's 100 times more. No, it doesn't, right? You generate it in pieces, but it has to have consistency across those pieces. So that's the thing they have to resolve. It has to, right now there's weirdness that happens sometimes with the videos, but like, okay, sometimes. So I'll render it again. And like, so you've got to go through some steps. The one they have now won't do it, but the next version of it might. I mean, that's how close it is. It's like within the next version or two, it's going to be.
And the next version or two costs another 10 billion?
I don't know. It's certainly that's been the pattern so far. And whenever I say to you guys, oh, I don't think so, then I'm wrong. So I'll just say, yeah, sure, whatever. But I don't know. They're like, why can't some of it come from just getting smarter about something within the model, right? They're doing this stuff with quantizing, you're getting your, your local models, your open source ones to be smaller and quicker and run on a phone or whatever. So like there's different innovation happening in all different parts of it.
Where's Apple in the AI revolution?
I don't know what this is with the latest talk of like Apple. It's just the thing they just came out with is better than GPT. Came out with means announced. They didn't really come out with it yet. But the thing that they're doing, and it's, what is it called? Realm, I think. It's an acronym. Yeah, it might be better than GPT at one specific thing, which is if I said, put that over there or something like where you're referring to something and it's better at understanding what you're referring to, they're going to probably come on strong. I give them a lot of credit for they don't jump out there at first, but then they figure out a way to have something really good. So and like also I heard that all this talk about the AI PC, AI getting incorporated into the next generation of laptops and everything, ain't all it's cracked up to be yet. Apple typically will have it be cracked up to something. Except for things like Siri, which is, a joke.
Have you seen the humane pin
device
that people have been, I don't know if you've seen, but today an influencer reviewer came out and called it the worst product he's ever reviewed. And most people have thrown the nails on the coffin and writing off humane as a failure at this point. What are your thoughts?
Yeah, I wasn't that interested. It looks similar to me to that movie I told you guys to watch that you still haven't watched, Her, because sort of it's around with you all the time. That was a dig. But it's around with you all the time, and it's like seeing the world as you see. I get better chance to something like I'm interested in what Facebook or Meta, whatever, does with their next round of those things, because there's something like walking around with big, goggles on your face or whatever that thing is, like it is not going to happen. But if you get something that's much more just like light, just glasses, and it does the kind of thing the humane pin does, then they were trying to replace the iPhone, and they came out of Apple, and these folks both had worked there. I don't give it that good a chance.
Yeah.
Did you see, John, that Meta released some kind of foundation model that is going to be used to benchmark like visual, how well a visual model performs? And in the example video, it showed somebody like wearing the Meta glasses walking around and be like, where did I leave my phone? And it's like, you left it on the kitchen counter, and you would go back and see if it was actually there. And I don't know that Meta necessarily has the technology that does that yet, but they've created a model that can test the accuracy of a model that's attempting to do that. So obviously I think Meta is working on their glasses being able to do that.
That seems like a doable use case.
Right.
It's kind of like the thing that Google was claiming to do when it didn't turn out to be video. It was like they showed it as if the model was seeing the video. Here we go. What do you got there?
Google Glass.
Google Glass.
15 years ago, maybe 12 years ago.
So, like,
whatever
what's
it
the
was.
difference between Google Glass? Google Glass is showing something onto your glasses, like a little overlay, a little archaic, but like a little overlay of something, little numbers, words. It's kind of like
I used to watch AC/DC music videos on these.
Oh, really?
Yeah.
So the thing is, it couldn't see anything.
Yeah, it can. It's got a camera.
No, that can't see anything. It's a camera. It can't
Okay, fair enough. It was not tied in and actually like recognizing what I was looking
Yeah,
at.
I'm sorry. So it was closer to like what do they call those? Like a GoPro, you know?
Yes.
It was like it could video something, but at the time there was no like vision recognition. So if Facebook Meta's thing could even do a, you know, one click every couple seconds or something of a still image that it goes and does the GPT-V type examination of what it had looked at, but then it has to do the thing of keeping track over time, having a memory about those things, which, you know, I think we're not that far, but that's really cool if it starts to be able to do stuff like that.
Yeah, it looks like that's at least the direction Meta's headed.
John,
yeah,
how much memory is all this going to take? Bryce and I missed the Micron first move here, but
almost none if you take the and here's something we talked about while we were at the Psych project many years ago, was when compression of an image can come down to being the sentence that describes that image. It's very small. So take your vision recognition, extract out the couple of facts about what's seen in that image, store away those couple sentences, and it took virtually no space.
You guys finish up. I have guests that just arrived. Peace and love. Good to see you, Johnny. I'll see you next Monday.
All right.
Well, thanks. The yeah, so on the memory deal, I was just reading an article though, John, that was talking about how on the on-chip itself, having enough memory and enough memory bandwidth is like one of the key limiting factors right now for these large models, especially.
Yeah, I mean, I really like that about the that Grok chip and the way that it's structured, because it makes it really like a pipeline architecture where it's always moving forward. It's not waiting for the rest of the chip to do something. It's always it's got like memory lined up next to processors and in rows. Think of like if you were, I'll use this metaphor. So, you know, you're sitting in church and you got and everybody is in all the pews lined up down the different rows, you know, and you're able to have the people doing the collection. There's a collection basket per row that doesn't have to get passed back. It's happening at the end of every row at the same time. That's how theirs functions.
Yeah, that's a great analogy. Do you like, how is there a difference in the hardware? Because one of the things we've talked about a lot is like ASICs, application specific chips. In the inference world, like where you're actually rendering, if you're doing video or if you're doing sound or something like that, do you know, is there a difference in the hardware that you're going to have an ASIC that is specific for visual processing, one for music processing, you know, one for movies? Like right now, NVIDIA GPUs are great, but I think they're general purpose.
Well, yeah, but I mean, look at how useful they were for how long was because of how appropriate the architecture was. Now you're going forward and it's like, now we need to get, you know, we need to squeeze even more out of it. So we're going to make these chips really, you know, specifically for solving these like large language model problems. But still, in both cases, whether you were doing video processing, graphics processing, actually sound as well, the notion of parallel processing of tensors, which are like 3D vectors. Think of a vector as being like a row in a spreadsheet.
Mm-hmm.
That's a vector. Think of a tensor as being the whole spreadsheet, or you got the tabs across the bottom, the whole set of spreadsheets that makes up that workbook. And imagine being able to like operate on the whole, every cell in the spreadsheet at the same time within a millisecond, or a couple, 20 milliseconds. That's the way the GPUs operated. That's the way the new chips operate. Yeah, they're fine-tuned, beyond that and everything, but that's what they have in common.
One of the developments, at least yesterday, there was an article from a semiconductor analyst that was saying that Google is not going to offer AMD's chips to its cloud customers. AMD has a AI accelerator called the MI300, I think. It's supposed to compete with NVIDIA's, and so Google is just offering their own Google TPU and then the NVIDIA, chips that they have on the system that their customers can use those in training or whatever.
Ouch.
So, go ahead.
Ouch for AMD. I mean,
yeah.
That's like that. What are they going to say?
Yeah, and that's been one of our things that we've learned in this process over the last year as NVIDIA has taken off, is just that it looks like NVIDIA is very disruptible. They have these very high margins. There's almost unlimited demand for the chips. AMD, Intel, somebody should be able to step in here and offer a competitor, at least on the general purpose computing side, what we're talking about right now. And it's just amazing that at least right now, there hasn't been widespread adoption of anybody but NVIDIA chips.
Do you, I can't remember the name of, I think it's a Dutch company that make the machines.
Yes.
That do,
ASML.
What's that?
ASML is the name of the company.
I'm a little scared of the single point of failure of, there's ASML and then who else is there?
Yeah, and on the advanced side, there's not. They have a monopoly on what's called extreme ultraviolet EUV lithography machines. Those are the machines that print the patterns onto the silicon that makes them work, that puts all, creates the transistors. And so, yeah, ASML is the only one in town. And we own ASML stock in the hedge fund, and we are long it for that reason. But yeah, if anything were to happen, and it's not an American company, you know what I mean? Like, we prefer to invest in domestic equity for the most part, but ASML is just too dang good not to own it.
Yeah, I think we might find that at some point the U.S. Invades the Netherlands.
Yeah, that'd be hilarious. Yeah, so there are competitors. I mean, there's Lam Research and then Applied Materials, AMAT, but they don't offer the same technology that ASML does. Same thing, right? Like, they're just several generations behind and can't seem to catch up. And for whatever reason, their technology is just top notch, and nobody else can get close.
Yeah. So.
John, did you watch the Masters this weekend?
No, I just saw a headline that said everybody was happy except the winner.
Yeah, so Scotty Scheffler won. I think he was happy. He said golf is the most unsatisfying career or something like that you can have, which I thought was interesting. But the whole time
remember when you and I went golfing?
Yeah, it was horrible. I tried to forget about that, John. But IBM Watson, which has been around for a long time now, but they were doing a ton of advertising. They partnered with the Masters to analyze every shot, and compare it to historical statistics. And, I didn't really look at it that much, but I saw the ads over and over again, probably as everybody else did that was watching on live TV. Do you know very much about IBM or Watson? And maybe you could tell us a little bit, like, what edge do they have, if any? I mean, have they built their own LLM? I don't even know. Or are they using, OpenAI's APIs or something?
I expect they're using one of the open source ones because they're wanting to, build on it on their own. They always come across to me like, oh yeah, we do all that stuff, like as if they are, right on the cutting edge with it. What they're really great at is kind of telling businesses what they can do for those businesses and kind of putting it to the communicating to the boardroom about how, what the things to watch for are and so forth. And I liken it to kind of I'm going to blank on the company's name we talk about, Palantir. I liken them to Palantir a bit in this regard, because they're kind of like, we're going to go help you from one end to the other when you have to produce your own X and such. So I think of it like that.
John, I think your 30 years in AI is nothing. IBM's been doing this stuff for 70. Where were you 70 years, 1950s?
Yeah, they invented the the abacus and the slide rule. They claim it all. Yeah.
So I don't know. I really don't know that much about Watson X, and it could be some legitimately exciting stuff in there. But I'm definitely with you in that historically, IBM has always kind of been like this glorified consulting company, especially since they really don't. They're not like in the server business really that much anymore, and they're not building hardware like they were in the early days of the company. And the stock's been performing really well, actually, and they've been playing this AI game a lot. But I just thought it was interesting that they're going all in on this Watson X AI marketing campain, and maybe there's something there. I mean, if they're willing,
they're
to
a consulting
company.
I think of them as a consulting company, and they happen to have some internal technology. They were able to show off Watson for some number of years there as being super cool. They're probably working to integrate what they had already done with that, with the language model stuff, so that they can show off some other cool tricks. But they've always been plugged into kind of what should businesses actually be concerned about with all this stuff. They'll try to get past the gobbledygook and layer on their own gobbledygook that Yeah.
Do you all use any IBM products, software?
My biggest kind of experience with them was when I was at Sitecore. We had a project with that we did jointly with the IBM Extreme Blue Lab, which was their innovation lab in Austin. And we kind of teamed up with them. They came in and checked out Site Technology. They had these like interns that were teams of software engineers and an MBA, like 2 software engineers and an MBA times 20 teams or something. And they went and each took their different approach to things and whatever. Super smart people.
Yeah. Well, I think back in the 80s, wasn't IBM, and it was Big Blue, right? And that was like where there was like one of the top places to work for people graduating in the 80s or something like that. Everyone.
Well, okay. So I left out that the other was it my first job out of college? No, it was after I came back from. It was in the 90s, and it was after I came back from 3 years in Bermuda. I worked at a place where I was the head of IT, and our main iron was an AS400, which is IBM computer running Fortran. And it was, got a team of people all doing whatever. And it was just so very different from what we, do nowadays. It was running how big was that? 100,000 square foot warehouse.
Jeez.
With all we sold children's clothing, the largest cataloger in the country. So we'd like send out 40 million catalogs around the country, and people would go and order their clothes and call into our 800 number. We had 300 people in a call center, and just they place their orders, and we go out and we fulfill it from the warehouse there. And the warehouse system was running on the AS400.
Wow. And I mean, look, I think whether it's from IBM or maybe even Palantir or others, like companies like Coca-Cola or Pepsi, we use those examples all the time, but old world UPS, old world companies, if you want to call them that, are seeing what's happening in AI and looking for ways to implement it in their business, right? And Coca-Cola's CEO is not a tech guy. He doesn't know OpenAI versus Llama versus Google versus what's a TPU versus a GPU, right? So I think there is probably a place here where the IBMs of the world are going into the boardroom and saying, look, give us a $200 million contract. We'll handle your AI. We'll help you integrate it, and we'll save you $1 billion in costs in fiscal 2024. And the
100%.
CEO says, yes, I'm in.
It's exactly how it works. Yes, 100%. It's kind of risk mitigation. They know they don't know. They trust this other business. They make a deal, and then they get it to happen. I just don't know. You got to try to work where you can get it into your company's DNA as well, because that'll only get you so far.
Exactly. And in the long run, the ultimate winners are going to be the ones that figure it out for their own, and maybe in partnership with a Google or a Microsoft or somebody like that has the actual compute resources. But yeah, I mean, you can't just rely on consultants for everything, I don't think, to be a successful company.
I mean, we're in the time of real creative destruction now.
Mm-hmm.
New companies will show up, and you always have this cycling through of different stuff. IBM, they figured out how to stick around for 100 years, but it's like new small businesses, new fast growth businesses will show up. Oh, let me ask you, what do you think of self-driving, like robo-taxis and so forth?
Well, we've written about it a lot if you're a Trading with Cody subscriber, but we're really excited about what's happening right now at Tesla, and there's been a lot of updates, and even in the last week or so. But number one, Tesla rolled out another update to the FSD software, which is called 12.3.4. I haven't driven a Tesla with that yet, but the 12.3.3 was great and amazing. And then Friday night, Elon tweeted that the cost of a subscription was dropping by 50% from $200 a month to $100 a month.
Oh, all right.
Yeah. And so, and they're also giving out free trials to everyone that buys a Tesla right now, a free 30-day trial. And then all Tesla users, if you didn't already have FSD, got a 1 month free trial.
So, but what about, I guess there are layoffs today?
Yeah. So then there was rumors over the weekend they were laying off a bunch of people. And then today they confirmed that they were laying off about 10% of the workforce, which comes out to like 14,000 people at Tesla. And then on top of that, two kind of key executives, C-suite type guys that have been with Tesla a long time, both announced their resignations from Tesla. And so there's a lot up in the air about, what's driving the layoffs and then the departure of these two executives. Were they laid off? Were they unhappy with Elon? Did they see the writing on the wall?
You had a big downturn in first quarter sales.
Yeah. So the first quarter delivery number was bad, and it's mainly been attributed to weakness in China. That's the biggest problem for Tesla, at least in the car business, is the Chinese competition. That company's called BYD is the main competitor over there. And the Chinese are good at building low cost products.
$10,000, something super cheap.
Yeah, literally they have a car that's like $12,000, like a mini EV. I think it's probably a glorified golf car, but nevertheless, if you're driving around Beijing, then that's probably all you need. You don't need a Model Y. And so anyway, so Tesla's faced that on the international front. Domestically, Tesla is continuing to kick butt, frankly, and Ford, GM, Volkswagen, all these companies kind of pulled back on their EV plans, and Tesla is, I think, obviously is not slowing down in the United States. But we're really thinking that this FSD, as good as it is, it's not 100% yet. I told everybody, I think it's like 95% the way there, and we need 100% basically before it's going to be allowed to have, no human in the car, in the driver's seat by the government. But it's so stinking close, you can see that it's coming. And then the rate of acceleration of AI is so fast right now that, we're pretty confident within a year or two that we are going to have, at least technologically, the capability to have cars that drive themselves 100% of the time without, with a 0.0001% failure rate. And whether or not the government approves that and allows Tesla to release those cars on the road is another story. But I think the technology is going to be here, and I think with time the government will approve that. And
Yeah.
Tesla
So
is shipping robotaxis.
what do you see as the structure of like robotaxi rollout eventually? Like you're just selling Uber a bunch of these and let them do it, so you don't have to get involved in the software of go pick somebody up thing, or they get their own Uber competitor kind of competition that they set up, or how do they go about it?
Yeah, we don't know for sure. We're also long Uber, and we love Uber. And we think Uber is going to partner with. We think for sure Uber will partner with Tesla and operate its own fleet of robo taxis. But the question is whether Tesla also operates its own fleet of robo taxis right now. Historically Tesla hasn't been in that business, and it's rather just would probably rather sell cars than get involved with all of that. And Uber's already got the critical mass of they've got the millions and millions of users that use their service every day. The pricing structure, Uber's got a lot of its own AI and matching up the quickest route, matching up drivers to passengers, all of that. So I think it makes a lot of sense for Uber to buy a fleet of robo taxis. But yeah, if Tesla has a competitor product and they refuse to sell robo taxis to Uber, that could be kind of an existential problem for Uber.
Yeah, I think it's much more likely to go ahead and sell to them. They could be a great customer to just get them as many as.
One of the reasons I wrote last week is for a support for my argument that Uber and Tesla are going to work together and not compete, is that Uber and Tesla already work together in a lot of ways. So like Uber has done a program where they're actually right now, they just announced in January of this year, they gave drivers a $3,000 stipend if they bought a Tesla.
Right. Yes.
Used it to drive Ubers.
Yeah.
And then, they worked with Hertz Rent-A-Car to offer, because one of the big problems for Uber drivers, especially like, an immigrant moves to this country and is looking for a job and can't find something. Well, he can drive for Uber, but he or she may not own a car and may not have the down payment to buy a car. And so Hertz worked with Uber and Tesla to offer the Hertz fleet of Teslas, at discounted rates to those kinds of drivers so that they could, at least get on the platform and start earning some money.
So there, another cooperation, just to make sure everybody knows, is Tesla and NVIDIA.
Mm-hmm.
The fact, you hear everything about NVIDIA and their chips and how great and so forth. And it's like, well, Tesla's in on that. They get NVIDIA chips. Yeah,
Tesla kind of hedged their bets and is tried to built their own AI chip as well that they call the D1. But Elon has said, I think Tesla would probably admit it's not as good as the H100, but because H100s are so expensive and so hard to get, Tesla went ahead and designed their own, because they're all in on autonomy, as Elon said. And so they've got this kind of parallel chip strategy.
What's the other, the NVIDIA? Well, there's a new NVIDIA chip that's the $30,000 thing or whatever, but what's the one that goes in robots?
That's
Rockwell or
the name of the NVIDIA chip.
Yeah.
So they have their Isaac program. Oh, Jetson is the name of the chip.
Jetson.
Yeah, Jetson. I'm sure an ode to the Jetson cartoon, but so the Jets, and that's been around for a while, but they actually just had some big improvements for it. And then NVIDIA has this kind of new foundation model, like software as a service type thing, where they're going to allow you to use their chips to power or to train robots in the metaverse, not the metaverse, the omniverse. And then, use that training data with a Jetson chip on a real robot, and it, functions without actually having to learn how to function in the real world. It can learn how to function in the omniverse first. So
there's a great kind of example of that where they show this robot hand in just an animated world, and it's learning to flip a pen between its fingers the way that some people do. It's a really great trick, and once it gets that down in the fake world, a fake world that has the laws of physics and gravity and friction and weight and all of the things that are like the real world. Once it can do that in the fake world, it can do it in the real world.
Yeah. I'm going to show this video here just because it's kind of hard to explain exactly what NVIDIA is doing.
Imagine.
Jim Fan is the head of that program in NVIDIA, the foundation.
Then help it teach itself. We broaden its understanding.
There it is.
That's what you're talking about.
To take on new challenges.
Yeah, essentially the robot learns in the digital world before the physical world. And then you can, I mean, I guess in the reasoning behind that, right, John, is just that it's cheaper and more efficient to train something in the digital world before you actually go to manufacturing and build the thing, right?
Well, that presupposes having a digital world that is real enough. And that they got to the point where they could make a fake world that was so not fake. And, that's what allowed them to be able to move from one to the other. And this is where Jim Fan, the guy who runs it there, says that the real world is just another simulation as far as they're concerned.
That's awesome. Because it feeds into the conspiracy theory that Elon always talks about.
The simulation hypothesis. Yeah.
So on that, how did NVIDIA get gravity or, friction, those physical concepts into the Omniverse? Do you know, did AI enable that, or was that someone coding it?
I don't think it was, it was existing in things like Unreal Engine. And so it predates things being just purely a model with just, numbers flowing through. It had to be people involved in coding aspects of that. I don't know where it is at this point, but like I'm saying, it existed back when NVIDIA was, making the processors for video games.
Yeah, I'd be interested to know if, like, even the Unreal Engine, if there was some, because Unreal Engine has kind of dominated the gaming space for a few years now. If they were, early integrators of machine learning and building out, such a real-time game engine. Because I know even before, like, Unity and Unreal Engine came around, gaming worlds had to be, like, programmed, right? Like, it didn't automatically render as the...
No, I mean, meticulously coded in C++. To do like all of the ray tracing and every kept coming up with new little innovations and techniques about how you make like a forest or a ground or fractal stuff. And yeah, amazing. You've ever played like a Grand Theft Auto or something like that type of a I'm trying to think, what do you call that, like a real not a third person shooter, but a first person shooter? Or that's a first person driver, but I haven't really, I just kind of watched it happen.
Yeah, because those types of games, like, you're in the whole world is like available to you, and you're running around doing whatever you want. You're not limited by
open world simulation or something where you basically can go on and on in whatever direction.
Right. I'm sure then Minecraft is kind of like the same concept. I'm sure there's some video game players on here that are laughing at us by our ignorance of this topic.
And then Sora was able to imitate like Minecraft, that kind of environment, be able to really generate this thing,
Exactly. Yeah. Because if you're going to make a full length movie, you kind of need that capability for the world to be continuous, right, as you move about it, and it's not like piece by piece and all of a sudden the dirt looks different or whatever.
So as a reminder or a recap here, we've got movie or video type stuff, we've got music, we've got voices, both that you can speak and it understands, or it can speak and it's sounding more and more like realistic and emotive when it speaks. You've got visual, like art kind of stuff. You've got on the language side, you've got generating almost anything that can be written down in any language. So like, what am I missing? It's like this, the number of things that are affected by these changes are seemingly endless.
Mm-hmm. Yeah, like is there a modality that we haven't conquered yet?
Haptic,
right? Like,
I guess. Yeah, just the
haptics.
Yeah.
In the Elon Musk biography, one of the things they talked about when they're developing the Optimus robot was how a human finger applies pressure and senses pressure simultaneously, right? And so when they were building the Optimus robot, they said, well, we don't have anything that can do both at the same time. And they're trying to figure out, how do we get a response back to the deal when it applies pressure to say, okay, this is how much PSI, right? And so they're like, do we put an actual pressure sensor in the finger or whatever? But just, it's phenomenal how
which they did.
Yeah.
So
I thought in the book, and they could have changed it, but they originally were just going to use the reverse pressure from the actuator in the finger as a read on how much pressure it was being applied without actually putting a different sensor in the fingertip.
Yeah, I don't know how they did it, but I know you can watch, when you watch like the demo of the Optimus like picking up an egg or something, they show like the fingertips across the hand, and you're seeing, green turn to red or whatever of like the level of pressure from each. So like they're doing it.
Yeah, amazing. And another reason we love Tesla as a stock is just the potential for the Optimus robot. We think is almost unlimited.
Yeah, I don't have a good sense of time frame. Like, I guess it's not as soon as self-driving gets all the way there or something. But I'm really interested in to see, when does a general purpose humanoid robot become something that you could use at home. You can go buy and just have around. Do
you think, like, is the humanoid form factor seems to be the prevailing path by all of the, Tesla and the startups?
Yeah.
Right. Is there, and, formerly it was Boston Dynamics. They had their one that like looks like a dog and others like that. Like, is it from here on out, do you think all of the investment goes towards the humanoid form factor, or?
I think the bigger money goes there, maybe, because it is kind of taken the lead, but all this other stuff is still happening. Folks are, making their little companies pop up, and they're like, we're going to go solve this particular problem, and it works to have these things. But the argument behind the humanoid one is that we have built a world that is optimized for humans to use this world that we're in. So things that are human size and shape are going to have the best time operating in it.
Right. One of the only other form factors that I've seen that's new that's come out is Disney's like droid thing that they introduced at the keynote, or I guess it was during the keynote at the NVIDIA GTC a few weeks back, and so, like, I don't know that those have practical use cases later.
Yeah, what's the point of it? I mean, it's cute, and it's kind of, there's, for entertainment. I just don't know what it's supposed to do.
Yeah, I mean, NVIDIA, Disney's in the entertainment business. So if they can make amazing looking robots that look just like something you saw in Star Wars, then, hey, that's valuable to Disney. Maybe not anybody else, but for Disney and those types of companies, Universal Studios and whatnot. That'd be
where they all need to find where they fit in the whole new world, right? Like, if Disney comes up and says, this is what we bring to it, and we have this huge background into, it's like, cool, partner with us. We're going to go, it matters how it, like, maybe there is somebody ends up with a in the home robot, and, Disney is their partner, because Disney's great at, the whole human interaction thing.
Yeah, they make you feel good, right? Like, that's the whole point of historically, at least when I was a kid, that's why you loved Disney movies, is the feeling you got when you watched it. And so they've got something figured out there. They've had a lot of Disney hate going around nowadays, but we also
Epcot was always my favorite.
What was that?
Epcot was always my favorite part of Disney World, and that's where they would show that they always had their eye on technology.
Yeah. Cool, John. We're coming up on an hour here. You have final thoughts? I guess you already kind of summed up where we've been, but I was going to say we are long Disney and the hedge fund too. So I like to at least disclose whenever, if I'm very bullish on something, I have a bias because we own the stock. So, but no, I think it's a lot of exciting things in AI this week, and full self-driving in particular is moving extremely fast. So that's kind of has our attention captured at this moment.
So I'll come full circle and just say, if anybody has not checked it out, go to udio.com.
Oh, yeah.
udio.com. Check it out. Click on a couple of songs. The thing is still in beta, so it's not great to use, and you don't have to get all into like, how do I make, it's easy to make your own song, but you don't have to get into that part of it. Just play a couple of them. Just see that this is entirely made by the computer. There's no recording of anything ahead of time. There was no voice. They didn't go grab this voice piece and make it happen, or, you know, these notes and make it. It's way beyond. It's not even understandable. It's magic.
Yeah, it really is. I made 4 songs this morning, and it gave, like, when I gave it one prompt, it gave me like 2 options to pick one, you know, kind of deal. And they weren't all great, but some of them were dang good. I was like, I listened to them a few times, you know, and it gives you a 30-second snippet, and you can like expand it and make it into a full song if you like the direction it's heading.
It can do comedy. It can definitely do, you know, rap. So it can do the spoken kind of stuff as well. Yeah. It can do any genre you can think of, and it sounds like something on the radio.
Outstanding.
Yeah.
Well, thanks, John, as always. And everybody, thanks for watching. Check us out at tradingwithcody.com and follow John on Twitter. And so make sure you don't miss any of his exciting things that he's watching throughout the week. And until next week, John, thanks for everything.
Take care.
Bye.